Hello, this is Paul from Forza Tech. In this lecture, we are going to find the arc length of a polar curve, and this is for the calculus for polar curve. Okay, so the last topic we did the area bounded by the polar curve, right? So here is the arc length. Okay, so first a summary, look at the formula. If we have a polar curve is this, and the theta, the parameter is between A and B. And the arc length is L equals from A to B to integration of this. Okay, so all this term is ds. So therefore, when we take a integration of ds, we get all the length, right? Why ds is this form? So here is a proof. Okay, I will go to look at the parametric equation first. This is the most important part for this proof. Okay. The parametric equation is x equals r times cosine, y equals r times sine, right? Okay, r is not a constant number here. R is f theta. R is a function of theta. Okay, r is a function of theta. Therefore, this is a product. Okay, if we're going to find the derivative, should we use the product rule? So now let's look at the ds. Is square root dx squared plus dy squared, and the differentiation. Okay, is a derivative times d theta, we factor d theta. So we have this. Or you can say is d theta per log n, and the cancel d theta, we get is still the same, right? Okay, now we need to find a derivative. Okay. And the derivative of x to theta, x take a derivative to theta, of course, is this term. See that the product rule, right? The product rule find the derivative of x, put it here. The derivative of y, we put it here. And then this is the perfect square, right? Perfect square, if I expand, see, the first term I expand on the first row, the second term I expand on the second row, and the middle term we just cancel. And the first two terms here we put together is our prime square. The second is r square, and put it together is r square plus derivative, okay, or the derivative of prime square. That's exactly what we need, right? R square plus derivative of r square. Okay, take a square root. This is the proof, and it's simple. Okay, so all we need is go from ds equals square root of dx square plus dy square, and they use the parametric equation. And then I will have two examples to show you how to use this formula. Okay, the formula. So we look at it. This is not easy to memorize. Okay, so but we do need this formula. And, can we see? Here, the first question. We need to find the length of the cardioid. So remember, this is the cardioid, right? Okay, the theta angle theta between 0 to 2 pi. All we need to do is what? Use the formula. Okay, now I will going to do a few steps. And a little bit of scale. Okay, I want a little bit longer calculation for this integration. And a little bit of scale. Please pay attention. Be patient with me. First, we need the formula, right? So the formula is easy. We just copy the formula. So the length L equals integration 0 to 2 pi, right? And then is a square root. Here is r square, and here is a derivative, right? Or dr d theta square, and then is d theta. This is the formula. Okay, first the capital is the formula you need. Okay, and then r we know, right? So derivative of r we also know. Plug into this, do integration, and then equals 0 to 2 pi. Okay, I put it here a little bit longer. And the first r is 1 plus sine, so 1 plus sine theta square. This take a derivative is cosine, so it's a cosine square d theta. And then now this is the perfect square. We expand, okay, the parentheses. So cosine square plus sine square equals 1. 1 plus 1 is 2, and the 2 plus 2 sine. Okay, I factor the 2 out, and therefore we have this. Square root of 2 is outside. 0 to 2 pi, and then here is 1 plus sine theta d theta. Okay, so this is a little bit new. okay, a little bit new. So we don't like the square root. So how to do? Okay, and here I provide one method, which is easy one. Okay, this is a very easy one. We can simplify the square root by using the double angle identity. Okay, later we will cancel the square root. So how to do this? The double angle formula is 1 plus cosine, so we have to change the sine to cosine. Okay, change the sine to cosine is easy, and we have a cofunction identity, right? So I've put here is okay, cofunction identity. Okay, it is 1 this sine, right? So we need the sine theta, we change it to cosine, equals cosine at 90 degree minus theta, right? Okay, so this is easy to change it to cosine. So I put it here first, which means square root of 2 integration. Now it is 1 plus sine is cosine pi over 2 minus theta, and then d theta. So 1 plus cosine is 2 times cosine square. Okay, so that's the double angle identity we need. I put it here as the double angle identity. Okay, is this 1 plus cosine, here I'll use alpha, okay, equals what? Equals 2 times cosine square at half of the angle, okay. So this time alpha is 1/2 minus theta. Therefore, we get a square, and they take a square root, and we can cancel the square root. Plug in, and therefore square root of 2, and take out square root 2 times square root 2 is 2. So I simplify a little, 0 to pi. So there we're going to this time square. Okay, square of this cosine square at half of this angle, which is pi over 4 minus theta over 2, and d theta. And now how to do? Don't just simply cancel the square root and the square, because the inside sometimes is positive, sometimes is negative. Okay, determine. So, but it is complicated. We need to do substitution to simplify. How would do this substitution? Okay, I do this substitution is what is I will use pi. Keep in mind it is a little bit difference. I will use theta over 2 minus pi over 4. Theta over 2 minus pi over 4. Okay, you see why is not do that? Because I wanted the limits a little bit easy to have a look. Okay, and if we plug this inside, and this time we will see what you have. After we do substitution, d theta we change it to du, right? D theta is 2 du. Therefore 2 make 4. So it is 4. And this time the interval, okay, you're going to find that the limit is going to this. This is what we like. Okay, from negative pi over 4 to 3 pi over 4. So it's go through the fourth quadrant, the first quadrant go to the second quadrant, right? Okay, so later we need to break this down into pieces, and then it's what is a square root of cosine square at u. Probably someone you say this is cosine negative u, right? It's okay, no problem. We have this, and the cosine negative u equals cosine u, right? Or square. This is the even function, and then is du. Okay, you plug the substitution go to here. So now we can break it down the integration. Why we need to break it down? Because the sign is different. Okay, so let me show you. So we're going to here, and the first quadrant for cosine positive. The first quadrant for cosine is also positive. However, the second quadrant for cosine is negative. Okay, be careful about the sign. Therefore, we need to break it down into these two parts. So the first part, we're going to do this. Negative pi, okay, I'm going to write it in this way. So 4 to pi over 2. You see, this is from the first quadrant to 90 degree, right? The first quadrant. And this is what? I'll write one more step. I will put here cosine square u, okay. And then no, this is the u, right? So I'll have to change. This is now no longer theta, is du. Okay, you know this is du. This is du. Okay. This is the first part. The second part is this. Don't miss 4. And the second part is pi over 2 to 3 pi over 2 over 4. So this time is for the third quadrant, right? The third quadrant, you know, what do we get? Later we get a negative. Okay, so now we can definitely define almost. So here is what is a positive, right? So positive means here is 4. Wrote one more step, pi over 4 to pi over 2. This time is positive, so we have positive cosine u and du. But this, what do we have? See? And the pi over 2 to 3 pi over 4. The third quadrant, this is negative, therefore we need to write this negative cosine at u. Okay, du. This is why you can see the difference. This is positive, this is negative. That's why we need to break it down into two integrations. Okay, now it's easy. You finally get it right. Okay, this is 4. Should it be sine u, right? Negative pi over 4 to pi over 2. What that? So this negative take out, so it's minus 4. And that derivative is sine. So sine u pi over 2, 3 pi over 4. So now I do calculation. So finally I get it. The answer is 8. Okay, a little bit longer calculation. You already see. I have the last question for you, which is to prove. Okay. To prove something. To prove what? Can you see this? Going to prove the perimeter of a circle with the radius a is 2 pi times a. Pi times the diameter is the perimeter, right? The perimeter, we learned this from we are very young, okay? It's from elementary school. So I never proved this for you before. Now I'm going to prove. Super easy, okay? So we look at how to prove. So first, we describe the curve or the circle in the polar curve, which is r equals a, right? A is the radius. How about the angle theta is belongs to 0 to 2 pi. Okay, so we all need. And then this is the arc length. The arc length is this way. How we're going to write? I will use the formula first. L equals what? Integration 0 to 2 pi. Okay, I still copy the same formula we just used. There's r square, and here's r dr d theta square, right? Okay, and then d theta. Okay, do we know r? Yes. Do we know the derivative? This goes to 0 later, and then our log everything 0 to 2 pi. Okay, so now what I get? I get here is a square. A is a constant number, and this is 0 square, which is 0, right? D theta. See how easy is the calculation? And then is what? This is a constant number. Okay, this is the, now you know, is the area. The area of a rectangle, right? Okay, area of a rectangle, of course. The first is the formula. Okay, if I have this, we use the height times the base. The height is this. Is you know, this is a. A is a positive number. Okay, it's a. The height times the base is 2 pi minus 0, and you know this is 2 pi a, right? See how easy, we already proved. Okay, so now you know how to prove the perimeter is diameter times the times pi, right? That's all. Thank you.